is about what I've got accomplished. I took the bead down to the surface here and to the surface here, you know, and then I hit it with primer, and then I put fingerprints all over it, which is really not that big of a deal. Today, before I go to work, I'm making this closeout panel. It's kind of hard to work with two fingers, but this guy, okay, so this guy, you'll get the picture here, but he goes in here, he goes in here. It does really, it does work. There. Along those lines. Establishes the window channel. And then you're thinking, how are you going to get the wiper arms out of there? So, I'm thinking that I do want to weld this in. Okay? And there's two modes of operation for the installing the wiper arms. One is to pull the, this is not the one. This is though. One is to remove it from the outside, pop it in, and then unthread it from the heim end. Heim end, that's what I said. The heim end, not the hymen. And so those screw on there, and of course it's a bit of a trick because this is flopping around, but the reality is I want to be able to get those in that hole and screw them onto there and not remove this. So I took the spare, and as it turns out, popping out the pressed in, you know, rivet pin rivet, popping it out and then cutting. You got about 4 threads in there. Quarter 28. Turns out I need to actually just step it up. It's 201 and quarter 28 is 213. I could have tapped it coarse, but I wouldn't have got enough threads, right? So I tapped and threaded to a quarter 28. I'll get a grade 8, you know, cap screw probably. This then needs to be opened up to a 1/4 of an inch. It just is, it's 201, 210. It's 201. I'm killing me. This is 201. That was 201, or this is a little bigger than 201 because it's a bushing. But anyway, so then I pilot drilled it with an F bit or E bit. Number 3, a number 3, and I did a test fit. I don't have a 1/4 inch fine, but I tested it with a, the shank of a 1/4 inch bolt and all that kind of thing. So I'm gonna go and pick up some 1/4 inch fine cap screws, 1/2 inch long. The stack up is 0.38, 380, a little over 3/8. So I'll put a 100 thou washer on, or 90 thou washer on this side and run it in there. And then this goes on like that, and then, or no, like that. This goes on like that, and then that'll be removable. Right? So then I could just pull this off and unthread it. Actually, on this one, and unthread it. Yank that out, and this comes out as an assembly. So it's not the easiest thing to line this up, but it's not an impossible thing to line it up, and I've got a couple of tricks that I'll use to make sure that I can get in there and get that. So that's the current plan, guys. So then I'll have my window channel all the way across. I'm gonna, you know, as well as that, I am going to copy that window channel around this radius too. So this will all be in, but I'll add more material to continue that radius all the way around. So when I put my gasket in there, it'll follow the form. It won't move while it's in the, already set up and in the windshield. So more later, but that's what's going on. Oh, and I ordered from Steel Products, I ordered three variations of window channel, just 1 foot lengths. They sell it by the foot, but I ordered 1 foot lengths. 3 different types, and then of course I was looking through the catalog and I found other potential opportunities. But I'd like to see a lip just come a little bit outside of here, and the reason for that is, well, couple fold. Number one, water can, this is radius, water can get in there. So if I have a lip, I'm moving, this is going to be a fixed glass, and so this would be the same profile. I have to just put the ledge on the bottom of this, because this was originally a roll-up window, but now with the hinges, it's intruding into there, so I can't get the window to roll up and down. I saw one rod where they actually made this post thicker, just moved this section here back and did the hidden hinges deal. This is the same thing, same type of channel, and basically on all these windows, once the window is inserted from the inside into the channel, then your garnish molding is all pushing up against that. On here, it'll be a combination of the dash and garnish molding around there. I'll put a header of sorts in here. I'll have to fabricate that and pick up all that goofiness. So the fun begins. We're back to fabricating. Yay! So I decided to cut this off here. I did do the old bolt-on trick. It's just, I just barely got it in there. And what I wanted to do then is close this out. I've got a little sanding to do, but close that out, clean up the rest of my weld. This flange then will weld onto the top. I'll continuously weld across the bottom. I'll close all this out, and I'll build my corner in here for the rubber seal. Now you can see it's just held on by a piece of tape up there, but look at that. So in this position the motor will be up, so I may need to relieve a little bit off of this. I know I'm running way too close, and then this comes around to here, to this side, and this will be right there. It'll be approaching the center, there you go, the center of that hole, and then it'll go up and it'll approach the center of that hole on the other side. So, well, you know what I mean, on the arm. So so close. Everything's going to be so close. But I'll probably go with this 10 gauge and just make a flanged opening here to weld on, and then kind of like the sheet metal is stacked sometimes in the bead. I don't have a good example, I guess, but a sheet metal thickness, but somehow I'm going to protect over the top of this, just so that the movement in there. And I may need to relieve out the seal, of course, above the show line, but it's just goes on and on and on. Anyway, I'm going to build this out, and then I got to, of course, copy all this on the other side. Okay, I got this piece done, sanded. That's the molding that goes up in the molding, whatever. The piece that goes up in here, okay, he gets welded on all the way around. This is a little bit raised so I can tap him down, and then my bead follows the window channel. Okay, I don't have it totally adjusted, but the whole point is, and then it steps in and all that, so I can get paint around here and get some sort of garnish on here. So now when you're at that phase, of course, you make your mirror image for your other piece, right? Mirror image, and then in this case I left the excess material on here so I can weld and then finish it, but oh my god, I got tape on here. So I made this in I'm trying to think it through here. I did make it in one piece, but now I put the tape on, took a razor blade, cut around the tape, because I am attempting to make a mirror image. This is probably not a revelation for many of you, but I just thought I'd show it. Now, when I pull my tape off, okay, I'm going to go to my waste piece. Whoop. There. Take that, draw around that, pull that off, roll it in and tack it up. Of course, I don't want to roll it just like that. I want to do the mirror image of that, so I'm going to roll it from, the other half of the circle. So that's what I got going. I'll keep plugging. All right, well, beauty of video, huh? This was the first one. This is the second one. And I think I showed, taped it off, made a mirror image. So again, the windshield wiper, they're separated. The motor's in this area here. The windshield wiper is here and here, for the drivers and the passengers. And this is the new channel for the molding, because I'm not going to have a window that opens out. So I'm building the channel, and this is where the actual post takes over, right? I need to address the stuff in the middle between the motor and each one of the arms. I did take an opportunity to round the arms where they were square, just because I'm keeping this close, just to make sure that I don't have any interference. So all that's done. The hardware is done. The channels for the windshield is done. I ordered 1-foot strips, 3 different profiles to test into here. And I just need to mount everything up and then start fabricating a removable interior piece, or just an angle iron, because I basically just need the channel at this point. I can lock the windshield in, easily up through here, rib nuts, whatever. I can easily get that put in, but they turned out very good. I'm proud of them, and they'll all get welded in here probably tomorrow. Time for me to go in. Okay, I got this welded in, ground. I got a little bit of body work to do there, but I sprayed it. Both sides turned out really good. They're all in there. And that little piece now is the channel that needs to continue, but that has to be removable so that I can take these guys out. So I just got it stuck in there. I have to relieve just slightly for this too and accommodate the swing. I may need to narrow this up because I think I'm just gonna wind up tapping it. So I'm gonna have to narrow this up a little bit. But basically, I'm putting a step in it by cutting a slot and then dialing it down so that I can get about a material thickness out. And it is just right, you know, I could just, oops, sorry, I don't think I was showing you. I can just, you know, I'm touching the bottom here, but I just need to get some relief on there so that that guy can swing. So that's what I'm doing. I tested the motor, the sweep is good. I assembled it. You know, these are welded in now, continuously welded across here, welded up here, welded all the way around here, down there, and around the corner. So I tied the corners in. I tested the bead, the rubber bead. I got 1 foot sections, and everything seems to work good. So now I got to figure out a way to get the rubber seal in, or the rest of the channel in, and that's what I'm working on. So I'll keep banging away at it.
Hey guys, just wanted to show you where we're at here. We are printing the 3D model design of the door handle. I built this up in 2D CAD and then sent it to my son who knows SolidWorks. And it's been sent to the printer, and we got about another 45 minutes before that thing's going to be done, but I'll give it a show to you here when I get it in my hands.
Hey guys, so I'm back in the shop and just kind of taking a look at, you can see that on the rear door, the profile. Now I can get rid of the holes above and below and all that stuff, but I wanted to integrate them. And traditionally, there's a weldment or weld nuts on the back side of a piece of metal. I don't have the light on in there. You can kind of see it from here. And on the top and bottom, where the door handle went on, and then, you know, in 1930, they would have used a standard screw from the outside to screw that on. In this case, I got rid of those, right? I got rid of those, and I'm going to thread from the inside out. And then I added, instead of a type handle, I'm integrating. In this case, the button's I just stuck that in there, but it'll be a push button. It'll be a door popper mode of operation. On this car, the window channel, where am I at here? There's that metal piece, but the window channel runs right down in front of, literally, the window channel you can see right here in front of it. So the Chrysler used or Dodge or whatever, used a piece of angle that went around and then behind the channel and provided the movement for unlatching the door. Actually, the latches were right here. That's right. They just had a linkage down to the latches. Well, the latches in this case, obviously, are inside because I'm using the bear claws. But I don't want the twist handle. I want to walk up to the car. I want a light with a halo. And I'm thinking some sort of proximity where my fob or RFID tag or something, where I walk up to the car and they all light up. Now they can turn on with the headlights and all that stuff at night, but from a practical standpoint, I'll know then that the doors are ready or are energized. And then you'll just walk up and you'll pop that and open the door. It'll be a door popper, but I mean, basically, it'll operate just like a regular door handle. Now in this case, the profile, it doesn't look bad. I like it, but I can go farther in. This hole is I mean, putting my hand there is huge. And I don't have the door profile, it's just taped on. I don't have this radius printed into this prototype. So he made this prototype. It has a bead on it, similar to the convex beads on the whole car. I was originally thinking ball milling and doing more of a channel than a bead, but actually when my son drew it up, he went this direction because he thought it looked better. And after looking at it in the 3D model and rotating it around, it just accentuates the car. So the concept looks like it's going to work. I'm going to reduce the depth. I'm going to put this curve in it, radius, the handle, so it sits flat and flush. There's plenty of room for the switch. If I take a half of an inch out, I still got this much room for the pigtail to go on and it to drive down the door to the poppers, to the relays that are going to activate the poppers. So everything looks like it's coming along. I love these little commercial breaks because they keep that inspiration, right? They keep you inspired. Obviously, I'm on the phase of building, the closeouts and the windshield wipers and the channel for the windshield, but this commercial brake really inspired me. I love the fact that it's one of a kind. The drawing came from my mind, went to my son's mind to model it and add his design elements, and then come back and produce that. And the profile, I think, is just cool. And so, because it's suicide doors, that will be jewelry just sticking on the side of the car. More than likely, I'll do them out of aluminum. I'll mill the whole things out of a billet piece of aluminum. Right now, we're under 2 inches max diameter, but I mean, I'll be taking some out, and I'm conscious of that too. What am I using for material, and how much do I have to, go up? It's not as vital, I guess, as I can go to this dimension, I guess, too, and mill it the other way. And then, of course, ease of machining. So if we do everything from the top, and you think all those things through, because you don't want, at the end of the day, of course, the prototype and the first build is always the most expensive. But I really think these have an opportunity. Let me know if you like this style. If you're interested in something like that, we have built out the design, and these will be machined out. So, and typically you person use brass or aluminum, and brass be a great foundation for chrome plating if you want to go with chrome. I've already told my story on chrome, so and it varies. Different people like different things. So that's where I'm at with this. This gets tabled now. I jot down my dimensions, put my radius in, update the print for the appropriate profile, and move forward. So they won't be machined it'll be machined before the car is done, but a while. But again, a fun commercial break.